We are just going to do one related rate level 3 problem. I'm going to show you how to handle the variable issues that you run into this. That's why it's called a level 3 problem, because you have the variable issues. As I promised you, we do have some nice steps that you can use on all related rate problems, especially the level 2 and the level 3. But a lot of times a picture will be helpful when you're labeling it. If something's not changing, you can use a number. If something is changing, you got to use a variable for that, and there's got to be a variable in the equation. And then we're going to translate the words into symbols, and we're going to get our equation. Now, once you get the equation, you're going to see what happens on this one. If it's a level 3 problem and you have variable issues, you must handle those first before you take the derivative. And then once you take a derivative, then we can plug in some things there. And then we're going to take the derivative and plug in some numbers as normal. So very common level 3 problem right here. Conical tank, vertex down, 10 feet across the top, 12 feet deep. So they're giving us dimensions of the tank. So I'm going to go ahead and draw myself a picture. Conical tank, vertex down. Now, when they say 10 feet across the top, I'm going to put a 5 right here, because typically all of our geometry formulas will have radius, like radii and height in them, not like diameter. So I'm going to use 5 for the radius, and then 12 feet deep for the dimension. And so that's the dimensions of that tank. So I can label those as numbers. Now, where the variables I need, we're flowing water into the tank. So right now it's empty and we're going to fill it up with water. Water is flowing into the tank. So at some point, the water level is right here. That's going to be a radius. And it's going to be up here. That's going to be a radius. So there's a radius at some point. And then right here is going to be a height at some point. So we got a radius and a height that's constantly changing. That's why I put those variables in there. And then I'm going to kind of read the rest of the problem. Translate the words into symbols. So I got my picture drawn. And then it says water is flowing into the tank at a rate of 10 cubic feet per minute. You got to think, what is that? Is that a DRDT, a DVDT? You're flowing water into the tank. So it's like it's filling up. So if you're filling up a glass of water, that's affecting the volume. Now I realize the radius and the height's also changing. Here's what also gives it away. It says cubic feet per minute. Cubic is automatically volume, how fast the volume is changing. So what they're giving us here is the dVdt is equal to 10 cubic feet per minute. And then you want to find the rate of change of the depth. Now depth, height, that's the same thing. But see, I want to use H for height, not D for depth, because all of our geometry formulas has R's and H's in there. So when I see the depth, that's the same thing as the height. And when it says 8 feet deep, that means that's like 8 feet high. Okay, that's all about the height. And so if you want to find the rate of change of the height of this tank, of the water changing, you want to find in symbols, that means we're going to find a dH dt. We're going to find a dH dt when the water is 8 feet high. So that's when the height of that water is 8 feet. So I got all my givens. Maybe read through that again, make sure I didn't miss anything. Real important that you can't use any of these numbers until after you take the derivative. If you plug it in before you take the derivative, you're assuming like that number is always that number when the stuff is constantly changing here. That's why we're working with the calculus. Now you have a volume and you have a cone. So I'm going to start with the volume formula for a cone. And just in case you missed that from the first video, there's some basic geometry formulas that we'll be using here. But if you need more of them, look them up, figure those out. Those will be given to you on a tested situation. Most time they're giving this to us on the AP tests. So that's something like real basic. You know, sometimes they won't give that to us. But I'm going to start with the volume of a cone, which is 1/3 pi r squared h. Okay, now you have two variables here. Some of you will just take the derivative of this as is. You won't even like think to use a product rule. You have a completely wrong derivative right there. If you take the derivative as is, that's like x squared times y. It's r squared times h. There's two variables there, which means you need to use the product rule. You shouldn't find yourself getting this complicated with it, all right? You're doing it wrong if you're making it that complicated. But if you, the problem with doing a product rule here, other than it kind of sucks to have to do a product rule, when you do the product rule, you would have r's and a drdt, and then you would have h's and a dHdt. Well, the h's and the dHdt is fine, but here's the problem. You got this variable in there, you know diddly squat about an r or a drdt. So that variable is a problem. It must go away before we take the derivative. That's what we're gonna do, okay? So that's why this is a level 3 problem. Not that it's crazy complicated, it's just you gotta do an extra step before you're ready to take the derivative. So here's how you're gonna handle the variable issues first, is sometimes they flat out tell us that the radius is 3 times the height. If they tell us the radius is 3 times the height, I go r equals 3h, I take a 3h, I plug it in for the r, and I got everything in terms of one variable. Sometimes two variables are going to be okay if you know information about those. Like we'll do level 2 problems where you have more than one variable, but you know information about those and you're able to find stuff. But if they flat out tell me the relationship, I'm just going to plug it in. But here they don't tell us that. That's why I chose this problem specifically to show you how hard that these can get. But this is about as hard as they get right here. If you don't know the relationship, you got to use something from your geometry days, similar triangles. All right, right here you have this little bitty triangle, and then you have this larger triangle right here. So you're gonna do like this side over this side equals this side over this side. So you can set up a proportion, r over 5 equals h over 12. And then what you do is you solve for the variable you want to get rid of. So cross multiply, you're gonna get r is gonna be 5h over 12. And still, do not take that 8 and plug it in. Do not take the 8 and plug it in there. If you plug that in there too soon before you take the derivative, you're saying that that height is always equal to 8, and it's not because it's filling up, it's changing. You need to take it, this stuff is still changing, but you're getting it in terms of that other variable, so it's still changing. You gotta take that 5h over 12, plug that in place for the r. That's how you handle the level 3 problems right there. Plug in something for the other variable here. And then, so this is still v. I'm not taking the derivative yet. I'm going to plug it in there and I'm going to square all in the same step. So that's going to be 25h squared over 144. And then that h is going to carry down. Don't take the derivative yet. All the time people want to take the derivative and make that too complicated. Simplify this first. All right, you can go, this is going to be 25, 3 times 144, I believe this is going to be 432. You have the pi still there. And then you have h squared times h, so you got an h cubed right there. So you have a number times h cubed. That's like a number times x cubed where you could take an easy derivative. So make it look like that first before you get all crazy with it. Now, once you have it looking like that, now we're kind of home free. The rest of this should not be the complicated part of the problem, but it's the beginning stuff. It's translating the words and the symbols. It's handling that variable. That's got to come some practice on your part right there. Now we're ready. This is just a level 1 problem. I have everything I need. It's all right there in front of my face. I don't have to read the problem anymore. Let's take the derivative with respect to time and plug stuff in. So let's go ahead and finish this thing. We're going to go dv dt. You're going to multiply by the power, so that's going to be 75 over 432. Remember to carry down the pi with it. You're going to multiply by the power, decrease the power by 1, and then you got to remember to tag on the dh dt because use the derivative of h's with respect to time. And now after you take the derivative, that's when I'm going to think to plug in those numbers, never before. So take 10 and plug that in. 75 over 432, that actually reduces to 25 over 144. So I'm going to reduce that fraction. And then the h, now we can plug it in because we're pausing the problem at the instant that water is 8 feet high. So you can plug in the 8 squared there. And then you don't know the DHT, but that's fine because that's what you're trying to figure out. But look how simple this is. It's all, you set up to solve this thing. You just got the one variable right there. So you could plug this stuff into the calculator. This is going to give us 100 over 9 pi DHDT is equal to 10. And then you're just going to solve this. You're going to have 10. You're going to multiply by the reciprocal. And then that reciprocal, make sure I can tell if that pi is supposed to be in the denominator. Make sure I can tell it's on the bottom part right there. So this is going to give us 90 over 100 pi, which means our DHDT, you can reduce that. You can make that 9 over 10 pi. And it's how fast the height's changing. So the height, check back there, we're just working with feet. It's not square feet. It's not an area or volume or anything like that. It's just going to be a height. So that's going to be feet per minute. And that's how fast the height is changing. Now, sometimes we'll plug that and say, I can just get a decimal just to see kind of how fast it is and just get a common sense answer, like how fast is that really going? But we always want to get those exact answers and make sure we include those proper units right there. So now, if you need to rewatch the level 2 problems video, you can rewatch those anytime you want, and you can rewatch this anytime you want, but we gotta be sufficient at all 3 different levels of the related rate right there. So hopefully those help you out, and just practice those. If you get stuck, you got to keep going back to this. Don't skip over that stuff. Don't try to do too much too soon. Get the givens down. Write down what you're trying to figure out. It's going to springboard you into what you're supposed to do next. And good luck with those, and we'll go through questions as you have them. Thank you.